Hello and welcome to 8th grade science. My name is Mr. Rogers and I'm going to be your teacher this year. This is the first in will be many different podcasts that we'll be doing this year. The goal of these, again, they're kind of pre-recorded lectures, so as a student your job is to watch them and take notes on them, and we're going to be using that Cornell method of taking notes we talked about before this video. So feel free to stop, rewind, or rewatch what you need to as we go through this. So our first topic is on the scientific method. In the scientific method, there isn't one or the scientific method, but more of a general term for how scientists think about the world. So what is it? What is the scientific method? The scientific method is a process scientists use to develop theories and explanations about the world around us. And so we're going to give you a list of like 6 steps. Are there sometimes more or less? Sure. But this is kind of the general process that scientists use to conduct experiments. So, the scientific method. We're going to click on the beaker to learn more. So the first step is to ask a question or identify your problem. What do you want to have an answer to at the end? And so we have kind of a sample here. The ones in purple, I think red too, you don't necessarily have to write down, but step 1 is to ask a question. And from that, you have to kind of gather information. What do you already know about the question? And in this presentation, we're conducting an experiment about plants, thinking about plants and what makes plants grow taller is our question. So now, step 2 is to form a hypothesis. And so for this experiment, again, you don't necessarily have to write down this purple part, but for our experiment, if I put fertilizer on a plant, then it will grow taller. And you can see in red there the if-then. The hypothesis typically is an if-then statement, which we'll see more of here. So a hypothesis is an educated guess based on your previous knowledge. What do you already know about the topic? It's also what you think is going to happen. So it is also generally an if-then statement, they call it. So if I do this, then this will happen. So it, excuse me, it really sets up your experiment. So if I do something, then this will happen. And that's generally how a hypothesis is set up. So moving on to step number 3 in the scientific method is to design an experiment. So in this case, for our experiment, they wrote, and again, I would not necessarily write down this one right here. I will take 2 bean plants and give them both the same amount of water and sunlight. One plant will get fertilizer, that's my variable, we'll talk more about in a second. And one won't get fertilizer, that's our control. So kind of the 2 big words there are variable and control. So what is a variable? A variable, and we're identifying the independent variable, is a thing in the experiment that the scientist changes. In this case, we're adding fertilizer. That's something we've changed about the soil the plants can be growing in. So now the dependent variable is a thing that in the experiment that changes whether the scientist measures. So because I added fertilizer, that should change the height. That's what changes because of it. It's affected by our independent variable. So independent variable affects the dependent variable. So we designed an experiment. So what's next? Well, step 3. So step number 4. Actually, did I click on step 3? We did. Okay, I was right. So step number 4 is to make observations. Record data. In this case, I will measure the height of the bean plant every day for 10 days. I'm going to record that information, record that height, that observation every day for 10 days, and hopefully that will give us some results that we can make sense of. So step number 5 in our scientific method is to analyze the data. So now we've ran the experiment, collected the data. So what does it mean? What does that data mean? We've got to figure out what everything means. And so for our experiment with the bean plant, you can see this is written in a data table. You can see down here, kind of a summary. And we're looking for patterns. What does the data tell us? Did the fertilizer help or did it not? So you can see here, looks like there's fertilizer in these 2 and then control. This way we did not add any fertilizer. And you can see it looks like generally adding fertilizer made the plant grow taller. I'm getting ahead of myself. analyze the data, we're kind of just comparing the numbers. What does that data mean? Trying to make sense of everything. And then in step 6, where I was kind of going already, is you got to make that conclusion. So you make a conclusion or draw a conclusion. There's some kind of big questions we have to think about. So what happened in the experiment? And so the bean plant that got fertilizer grew taller. Our data shows that. Why do you think that happened? And again, I think the fertilizer made the plant grow taller. Fertilizer is designed to do that. Did your data support your hypothesis? It seems to support that, yes. My hypothesis stated that if I put fertilizer on a plant, then it will grow taller. The results showed that my plant got taller with the fertilizer. So these are kind of the basic steps in the scientific method. I'm going to do a quick recap here. So step 1, ask a question. Step 2, form that hypothesis from that question. So develop that answer to your question also. Your hypothesis should give you what you think is going to happen. So you have to design that experiment, and your hypothesis should really do a good job of kind of setting up what you want to do. So design your experiment. How are you going to collect data to test your hypothesis? Step number 4 is observe. That's collecting data. You got to collect your data. In this case, we're making observations. Step number 5 is to analyze the data. Try to make sense of it. Does it seem plausible that your results are true? And then step 6, we're trying to make sense of it all. Does our kind of record and report what happened in our experiment? It's a very important part of that conclusion, because we're wrapping everything together. What you thought was going to happen, what actually happened, and why did it happen that way? A lot of things happening in there. So we're going to stop there.